So, today's class, we will explain exploded views, which are assembly drawings. This is again one of the methods, one of the types of drawings, we would say, that is used sometimes in design. Not always you require an exploded view, but if any of the item that you're designing, any of the object has a lot of parts, it is advisable always to have an exploded view as part of your engineering drawings, because this will clarify each part, what it will be, and how they come together. So, exploded views show objects blown apart to see how they fit together. So which part goes where. So it's like an instruction. Like if I look at the object assembled, which means like this table, everything is now together, all the parts. Maybe I don't know if I receive it in separate parts, how to assemble it together. So it shows you how you can assemble something together and disassemble together, apart. Also, it shows, if you draw this kind of drawing, anyone who view it knows each of the parts, knows exactly how many pieces you have, what is their size. So anybody can make, produce, manufacture your designed idea. So all of these parts are clearly visible and where each of the parts will come together. So these drawings are very useful, as I said, if you have designs that have several parts. And most of the designs have parts. This table is made out of many parts. This chair is made out of several parts. Any design, some designs have hundreds of parts. Some designs are more simple with less parts. But if you're designing any object, it has parts most of the time. So these kind of drawings are very useful in this regard. Now, so it shows an object, basically everything apart. Normally, this kind of exploded views are drawn as isometric. So if you put, for example, here a line, this will be at 30 degrees, this will be at 30. And notice that all of the parts are at 30 degree, at isometric. So if you put a line here, this will be 30, line here 30. So all of this is exploded in an isometric view. Okay. Now, each piece is shown exactly in the order of assembly. So this is here the bottom piece of this mobile. This is the top piece. And in between, we have all these pieces in order. That means if I look at this, I know, okay, this is the first piece, come at the bottom. Then I need to put this piece here. Then this piece exactly, if I put two lines, comes in this area. This piece, if we put the lines down, is located in this area. Each of those pieces, when we put lines down, we know in order which piece comes above which piece, and also their location. So, if I look at this object, and you give me the mobile in pieces, and I look at this drawing, I know exactly how to put it together, assemble it together, okay? Because I have this instruction now. Each piece, I know where it belongs, where it should be attached, okay? So, now, you need to pay attention to something. So, all of this is done in isometric, as you can see. Each piece, if you put a line through it, it has 30 degrees from here, 30 degrees from here. All the lines are parallel, the isometric rules. Some of the pieces, there is an axis, okay? So these pieces come on top of each other, okay? Assembled like this. So they follow the vertical axis, okay? All of these come like this together. But sometimes you have pieces from the side, from this side, from this side. So you have this axis, the vertical axis. You have this axis at 30 degrees, and this axis at 30 degrees. So any pieces from the side, depending on what object you're drawing, there are pieces sometimes from the side. So these have to be drawn according the correct location. So this piece, for example, attaches from this side. So this is drawn at 30 degrees from this side. This piece comes on top of this piece. It is drawn according to this axis. So, here are some other examples, as you can see. So, again, if you put a line through here, this is 30 degree, 30 degree. All these lines are parallel to each other. This is isometric, okay? All the pieces, look, there is the vertical axis. So, this is the bottom piece, then this comes on top of it. Then this object, if you put here the lines down, exactly fit into this space. This spring exactly fit in this location, okay? So this object, if you put it down at 90 degree, the vertical axis, it fits here. So in order, now look at this object here. This is from the 30 degree angle from the side. This object does not, it fits on here, on this object from here. This, where does it fit? It fits inside this hole, but it comes from this axis, okay? So the 30 degree axis from here, it has to be drawn, exploded in this direction because it fits in here. If they fit like this, you follow the vertical axis. If there is something from the side, you follow this axis. If there is something else from this side, you follow this axis, like these objects. So it really depends on what is it that you're drawing. Here also most of the objects follow the vertical axis. This is how they come together. Then you have these at the bottom which enter into here, and so on. So we can see exactly which piece fits where very clearly, okay? How to assemble or disassemble an object. Here are other examples. Sketches of other objects, the same thing. This is a mouse, this is a shoe. Even shoes have different layers and parts, everything. Most of the items we design are made of many parts, and we need to show it. If someone wants to manufacture or make this shoe, they need to know how many parts do we have, how does each part look. Then they also want to know the materials of it, but this is additional stuff. But we need at least to see the parts. So this part, this part, this part is the upper part, and they come together in this way. So this is very important to show the shape of each part and how they fit together, how they assemble. So why is this again important? Because each piece will be manufactured, made alone. So this piece will be made, then this piece will be made, this piece will be made, and after that someone will glue them together, if it's a shoe, okay, and stack them on top of each other. If it's a mouse, we have a lot of parts here again. So each piece will be manufactured separately, and then someone will take these pieces and put them together, okay, assemble them together. So these drawings are crucial in this regard. If you don't have this kind of drawings, exploded views, you will not know what you are designing, how each piece will look, the measurements, how they will come together. This will be not very clear. Here is another example. Now the previous drawings, we saw most of the exploded view is in a vertical axis with pieces from the side, for example, here. Most of it is in one of the 30 degree axis because of the object. This is a camera. How does it, if you explode it, how it will go? There is pieces that come from the top, of course, and the bottom, and the side, but most of it goes this way. Okay, so you open this piece, and you open the back piece, the last one here, the front one, whatever piece it is, and in between you have an exploded view of all the parts that fit in their correct order. Which part to put first, which second, which third, and so on. And then you have the final camera. It has a lot of pieces, okay? So imagine if we don't have this drawing, how will this be manufactured or assembled? It will be very difficult to understand. Now, in exploded views, often they have for each part a name, like for example, what is this part? Sometimes they leave it as a number if you don't know the name of each of the parts, and there is additional information about it. Like for example, okay, Like this part, what is its material? Okay? So you have here a table, it's called a parts list. You will be doing these things, but in the project. Okay, in the project. So there will be a parts list, for example. Okay, what about this part here? What is this? Is this made out of plastic, glass, any other metal? We don't know from the drawing. So it's stated in the parts list, the material, the size of each of the pieces, a lot of details, the finishing, the color. Okay, so everything about these parts is stated in a table here, in this kind of drawings. A desk, okay? Even a desk, a simple desk is made out of many parts. Each part, if this is wood, for example, or have wooden elements and metal elements, each one of these is cut separately. Each one of these, we cut them separately, okay? And then we assemble them together. And if you are the designer of this, you have to figure out exactly how each of these parts will look. Imagine you're designing a furniture piece. It is not about drawing a sketch on a paper. After the sketch, you need to figure out the measurements. The measurements of what? Of each part. And each part, when it is cut, manufactured, and put together, assembled together, they must fit perfectly. So, where does this belong, okay? So this is here from the side. So if we take the lines at 30 degrees, it should fit in their correct location. Each of these parts should be shown how it fit together. And they should fit perfectly. Any mistake in any of these measurements, after it's cut, after it's manufactured, and someone will assemble them together, they will not fit. And this is a big problem. So you are actually the designer of all this. If you are designing a table, a desk, these things, you are the one who figure it out. And one way is to draw, besides the orthographic drawings, besides the other types that we talked about, an exploded view is necessary in this kind of drawing. And why isometric is used? Because the isometric show the actual measurements. It's not a perspective drawing to fool us or not understand the measurement. Isometric uses the actual measurements and it shows you exactly. So you can draw this drawing scale 1 to 1, scale 1 to 2, scale 1 to 10, and then I can exactly know each piece, what is its measurements. Exactly, from the drawing. I can measure it, and okay, this is 1 to 2 scale, so it's 2 times smaller. So this piece times 2, I know its real size. And I know exactly what to make, how to make it. Here are more examples, the same thing. Look, this is the object. Look how simple it looks, but it is made out of many parts. Okay, so looking at that, we don't understand how many parts do we have, how do we cut it, what is the size of each part, some parts are hidden, some... Okay, so we need to show the exploded view and know exactly each part and its location, okay? Look at this. Simple chairs that we see every day, but at some point they were designed by someone. This someone figured out each piece, where is it going to be located, how is it going to be assembled, to the last detail. These are what? Okay? The objects that fit one piece to another piece. Even they have sizes. They are usually made out of metal, pins, screws, whatever. There are many different types. If you use it in your design, you have to know what are you using and where does it fit. According to these lines, we understand where each of these objects fit together, okay? When we put it, assemble it together. Let me see here, what is this? Yeah, okay. So, the exploded view of an object starts as usual. We have the first edge, then we will draw 2 lines at 30 degrees, and then the first thing you will draw is the bottom part of the object. Then, what comes on top? then what comes on top? All of them at 30 degree. Okay? Here is a simple example. That box in exploded view. So what do we have here at the bottom? Okay, this piece. This is at 30 degree. This is the first edge. Okay, great. What is its thickness? What is its length? The width, the height, all of this stuff. Then you draw what happens next. These pieces fit here. This piece comes from the side at 30 degree, fit from here. This piece. Okay, come from here. There is also a piece that comes from this side, which is this. And here we can see its shape in detail because it's exploded now. And then the top piece. And look at this piece here with these vertical lines. It shows you exactly where it should fit. That's why it's placed here. It's exactly in the middle. Now, if you in your drawing draw it here, this will mean to the viewer that it's located here. So these straight lines down and the lines at 30 degrees from both sides indicate where the object will be. This is very important, not to shift. Like you cannot draw this here, because it will mean that it will go this way and fit here. Okay? Now we know that it goes this way at 30 degrees and fit in this location. So be careful where you put the items. And there is only 3 locations. Vertical, 30 degree, 30 degree. Okay, that's it. Okay, these lines are usually drawn very light or with small dotted lines so that visually we can understand each piece where it's fitted. In some of the drawings they leave them out, but this way it's more easy to understand. Now, the spaces in between. Let me go back to this drawing. Okay, for example, this. Now, each piece, maybe someone will ask themselves, okay, how much space to leave between each piece? This is not important. Important is that, okay, if we have a lot of pieces, we can put them closer to each other. But try to keep the spaces, like whatever spaces you choose, try to keep them as equal as possible. Not, for example, to have this piece here, and then this piece that much far away, okay? So, try to keep them as even as possible as you explode the object. Of course, as you can see, some objects are drawn closer, like this is drawn closer to this. So, it's not like a fixed rule that they have to be equal, okay? Some objects you draw them closer, some far away. But overall, when we look, we don't want to see one object far away, one object very close. It's just visually not good. And so this spaces, it depends. Like if I have a lot of parts, I will reduce. If I have a few parts, I can leave more space only. But you need to be careful not one part to obscure another part. Like if you put them too close to each other, maybe this part will be kind of hiding some of the features of this part. Sometimes it's okay when the hidden part is not such an important, or for example, it's clear that it's a symmetrical object. Okay, what we have from here, we have from here. But be careful with objects overlapping while you explode. So leave a sufficient space so that we can see the whole part. This is more better. Okay? We can see the entire part, how it looks, without hiding any element. So this is the thing that you need to be careful about. Not to put them too close to each other and start overlapping the different parts. Here again, as you can see, we can see clearly all of the separate parts. So this is advisable. Now here, do you see how this object, what we talked about, it overlaps this part of this piece. But in this case, it doesn't cause any problem, okay? It doesn't cause any problem for the understanding of the object. But if it overlaps and hides important parts, then it is problematic, okay? So just keep this in mind. Here again, all the parts, as you can see, we can see them separately. Nothing really overlaps and hides pieces. So, now, the last exercise for this section, exercise 13, it's optional. That means who do it gets extra points. Who don't do it, well, no extra points, okay? So this is optional. If you want, do it. If you don't want, don't do it. Exploded views, we will draw, but in the project. So you still need to know about them. If you want, do it as a practice. And this is a very simple exercise. So we have here this lamp. As you can see, how many pieces do we have? We have this piece here, we have this piece, and we have this piece, 3 pieces only. Now, according their order of assembly, you need to draw them in exploded view. Now, as you can see here, it's already in isometric at 30-30. You just need to explode the pieces according their order. So, do you need the vertical axis? Is there any pieces from the side? No. Just the vertical axis, okay? Scale 1 to 1. Now, here we don't have any measurements, but each of these spaces, this is the grid, the isometric grid at the back, each of these is 1 centimeter, okay? So, each of these 1, 1, 1, 1, 1, 1, 1, okay? So you know, okay, what is the height of this object? It's 1, okay? What is the length of it? 1, 2, 3, 4, 5, 6, 7, okay? By how many? So, every space is 1 centimeter, so that you know how to draw it scale 1. So, you need to draw the isometric view on the left side of the paper, and then draw the exploded view on the right side of the paper. So, so we will have the paper, the A3. Here we have this object as assembled together, and from this side exploded in isometric. That's it. Now, until now, you should have completed 13 exercises, which equals to 15 drawings, because some exercises we have 2 drawings to do, okay? So, 15 drawings and 1 optional, the last one, okay? So, but you must have, every one of you, 15 drawings for submission, okay? Next class, we will have an exam from 15% and the submission of all your drawings. So you will come to the class, you will submit your drawings, please in order, okay? Don't forget to print the labels, okay? And make sure not to make a mistake in the labels. Like, for example, you need to mention which exercise it is, what's the name of the exercise, okay? So these kind of things, be careful with them. The scale, because each exercise has different scales, okay? Just be sure not to make mistakes. So the labels need to be printed, glued. You can also either write the views, but very clean way, so top view, side view, front view, or you can print labels again and glue them in a very clear and nice way. So this is, you choose what you want. So you will come next class, you will submit the drawings in order, okay, here, in a file or whatever. If you want to submit them just as drawings, it's okay. And you will sit to do the exam. The exam, as I said before, it will consist of some multiple choice questions and some drawings that you need to do. So you need Fabriano, you need your rulers, pencil, all of this stuff to be with you. Okay? Any questions?